All right. This next thing comes from page 263 in your textbook. Please don't write down this first part. I just want to talk to you a little bit about page 263, and then I will have you start writing down some things when we get to the examples. First of all, any fraction can be expressed as a decimal by dividing the numerator by the denominator. Remember when we were changing those improper fractions to mixed numbers? We divided that top number, the numerator, by the bottom number, the denominator. Well, that can be done to any fraction. Even if that top number is smaller than the bottom number, you can always put the top number inside the division bar and the bottom number on the outside and divide. And what happens is they say you get some kind of repeating decimal. Now, I kind of disagree with that, but for the sake of argument, we're just not going to argue with the book. Just know that the last number could be a repeating zero. You can always add zeros to the end of fractions and not change the value of a fraction. So a repeating zero is still a repeating decimal according to the book. Repeating decimals can be represented using bar notation. In bar notation, a bar is drawn only over those digits that repeat. So if you get a decimal of 0.33333, you could just write 0.3 with a bar over it. If you get a decimal 0.12121212, you can just write 0.12 with a bar over it. But look at this one, 11.3858585885, whatever. Only the 8 and the 5 are repeating. That first 3 doesn't repeat. So notice how the bar only goes over the 8 and the 5. If the repeating digit is a 0, the decimal is considered a terminating decimal. Now, here's that thing that I was telling you about, that they say a terminating decimal has a repeating 0. Okay, I think they're just getting a little bit ridiculous with that. We would not write that. That's not how we would write it. We would just write it as 0.25. So terminating decimals do not have to have repeating zeros on the end of them. So let's quickly just match up these decimals with these repeating decimals with their bar notation. So 0.111, hopefully that's obvious for you to see that that would be 0.1, 0.61111, because only the 1 is repeating. We would match it with that one, and that leaves these two as a match because the 6 and the 1 are both repeating. Next page, let's go. Down at the bottom of page 263, it says, Jamie had 2 hits over her first 9 times at bat. To find her batting average, she divided 2 by 9. So notice how this is written. The first number is the number that goes inside. The second number is the number that goes outside. You may also see this as 2 over 9, where the top number goes inside and the bottom number goes outside. It's very important that you realize that size does not matter when it comes to division. The first number listed, when it's listed like this, and the second number listed when it's listed like this. The first number goes inside, the second number goes outside. When it's listed as a fraction like this, the top number always goes inside, the bottom number always goes outside. That is the dividend and the divisor. So when you divide that, you got to add a decimal point and a 0. 9 goes into 20 only 2 times, and you get 18. Well, notice you get 2 left over. You have to add a 0 and bring it down. You started out with 20. Now you got 20 again. So what's going to happen is you're going to get this repeating 2 over and over and over again. You're always going to get 18 when you multiply and 2 as a remainder. And it's just going to keep going over and over and over again. So to write that in bar notation, you would just put 0.2 with a line over it. Now it says round that to the nearest thousandth. Well, thousandths place. You might want to look at the place value chart on the right-hand side of the room to see that the thousandths place is the third number. If I'm rounding to there, I want to look at the fourth number, the 10,000ths place, and you will find that that 2 doesn't make the third 2 go up. So it would be 0.222. Turn to page 264. On page 264, it says our decimal system is based on the powers of 10, such as 10, 100, 1,000. If the denominator, that's the bottom number, the denominator of a fraction is a power of 10, you can use place value to write the fraction as a decimal. It says complete the table below. Write the fractions in simplest form. This I do want you to quickly write down. You don't need to draw the table. I just want you to put that 7/10 is equal to 7/10, which is equal to 7/10. And by the way, all three of those are read the same way. 19/100 is equal to 19/100, which is equal to 19/100, where the 9 is in the 100th place. 105,000ths is equal to 105,000ths, which is equal to 0.105. So 105,000ths, where the 5 is that third decimal place, or the thousandths. If the denominator of a fraction is a factor of 10 or 100 or 1,000 or any greater power of 10, you can use mental math to find its place value. So let's take a look at some examples of that. If I can get the page to change. It really does not want to change. There we go. It says write each fraction or mixed numbers as a decimal. This is 264, example 1, and yes, please write it down. 74 over 100 is equal to 0.74, 74 hundredths. They are the same thing. Example 2, though, is not quite as simple. You have 7 over 20. Well, 20 is not 10, 100, or 1,000, but 20 is a factor of 100. There is a number I can multiply times 20 to get 100. And that's what you want to do. You want to multiply not only the bottom, but the top by 5. Remember, that fraction is equal to 1. That fraction is equal to 1. And so I get 20 times 5 is 100, and 7 times 5 is 35. So I can write that as a decimal easily by just putting 0.35 or 35 hundredths. 35 hundredths. Why don't you see if you can't change some of these problems down here from decimals or from fractions into decimals by finding something to multiply the top and the bottom by to get, well, I guess on that first one you don't need to do that. By finding some way to write them as a fraction over 10 or 100, and think about what you would do with this whole integer. Where would that go in relationship to the decimal? Would it go after or would it go before? Remember, you're only changing the fraction.